It's Mark from Math 150, Section 666.
Alright, so we're going to pay attention to Chapter 6.1, Number 10. Suppose the following data represent the ratings on a scale from 1 through 5 for a certain smartphone game, with 1 representing a poor rating. Complete parts A through D. Letter A. Construct a discrete probability distribution for the random variable x. Remember that the probability of x must equal to 1 or 100%. Chart lets us know the ratings, which is represented through stars, and its frequency, starting with 1, 2602, 2, 2888, 3, 4949, 4, 4906, and 5, 11622. To find the probabilities of each star, we're going to look at the frequencies and divide that by the total, which is 26,967. Create a new chart, and that's how we get the decimal places 0.096, 0.107, and all these are basically the probabilities of the stars, with 5 being 0.431. As I stated earlier, these probabilities are going to add up to 1, which is 100%. He says, draw a probability histogram. So by looking at our new chart, we are able to create a probability histogram, which you see here with the x-axis and y represented as the probability of x, starting from 0.1 and so on, and 1 to 5. And we can see down here that this value is clearly the same value here, and the fifth value is clearly the same value with 0.431. That is what it's representing. B. Compute and interpret the mean of the random variable x. So by looking at the new chart, we're just going to input that data to the list in our calculator and use technology to solve this. So list x will be in list 1. The list of p of x would be in list 2. It should look like this. With a list in our calculator, we're going to use this equation: one variable stats, parentheses, list 1, comma, list 2, close parentheses. Now, how to find this is by clicking stat and calc. One variable stats, number 1. The answer, 3.7 stars as the mean. So what does this mean? The number of experiments n increases, the mean of the observation will approach the mean of the random variable. Pretty much, it's what we learned in class when our professor was flipping the cup hundreds of times and seeing the values. Compute the standard deviation of the random variable x. Now, if you did the last equation I showed you, you should have the answer, and it'll look like this. This value right here, 1.35, or round it up to be 1.4 at 1 decimal place. So now that you know this problem, go ahead and do it yourself.